Okay, in the last video we had discussed up to that chart, right? Figure steps involved in the extraction of metals from ore. So we have discussed already the extraction of metals from its ores. For this purpose, they have been classified as metals of low reactivity, metals of medium reactivity, and metals of high reactivity. Accordingly, what are the procedures? It has been discussed already. Now, enrichment of ores. These ores, when they are mined from the earth crust, right? So they don't exist, or they don't found as directly ore. Rather, lots of impurities, soil, sand, etc. are attached with these ores. Okay, so these impurities are known as gangue. So some impurities are attached with this ore while we are just getting or obtaining this ore. These impurities are known as gangue. Now you know that for the purpose of next procedure, or to obtain the metal, at first we need to remove these impurities, right? And how they have been removed, this is on the basis of their physical and chemical nature. Suppose if the impurities are soluble in water, then what would happen? They will be allowed to dissolve in water. Now suppose if these impurities are the substances which can be separated by using the magnet, that is, if these are magnetic substances, then by using magnet they can be separated from the ore. That means on the basis of their physical and chemical nature, these impurities will be separated from the ore. Now let us come to the detailed discussion of extracting metals, those who are placed in the law of the activity series. So you know that in the law of the activity series we have the metals like mercury, copper, gold, silver. These are the metals which are found in the law activity series. Now for the extraction of mercury from its ore, already we have discussed that metals of low reactivity, they are mostly found in sulfide ore. You see, metals of low reactivity, they are sulfide ore. Then if it is sulfide ore, we used to go through the process known as roasting to obtain the metal, right? Now you see, as mercury is positioned in the low activity series, so one ore of mercury is taken, which is there is cinnabar, HGS, right? HGS, cinnabar, which is an ore of mercury. Now how it is done? First you see, this is the mercurous sulfide, HGS. When it is allowed to react with oxygen with constant heating, then what would happen? Mercurous oxide will form along with the release of sulfur dioxide gas. Now you see, at first we have taken the ore HGS. Our target or our attempt is to remove all other substances which is attached with the mercury. So here you see sulfur. So first our aim is to remove this sulfur, right? Or to delete this sulfur from mercury, because we are going to obtain the mercury only. So for this purpose we are going through the process known as roasting. And in roasting, what is done? The ore is allowed to react with oxygen in excess amount of air. That is, in excess air the ore is heated so that it can get combined with the oxygen. So at the very initial step, what would happen? Sulfur dioxide gas would get released and oxide of that particular metal will form. Okay, now after obtaining this oxide of metal, as heating is going on, constant heating is going on, so this oxide later on through heating it will release, there is mercurous oxide will release oxygen gas to form mercury. That means we have obtained mercury. So this is the process how mercury is obtained from mercurous sulfide. At first it is allowed to react with oxygen with constant heating, then oxide of mercury will form along with the release of sulfur dioxide gas. Now this oxide of mercury, as heating is going on, so it will again decompose. As a result, oxygen gas will be released and mercury in the form of liquid it would be obtained. Similarly, if we consider in case of copper, here you see Cu2 as taken, right, which is an ore of copper. When it is allowed to react with oxygen with heating, then we are getting the corresponding oxide of copper along with the release of sulfur dioxide gas. But here what is done, this oxide of copper again used to get combined with what, this copper sulfide, okay, and as a result we are getting copper and sulfur dioxide gas. So ultimately here the two examples taken for extracting metals which are placed in the low activity series. So those metals which are found in the low activity series, they are mostly found in sulfide ore, or from the sulfide ore it is very easy to extract these metals. Then from the sulfide ore we will go through the process known as roasting, and in roasting what is done, the ore is heated in excess amount of air, and as a result corresponding oxide of this metal is formed, and from this corresponding oxide in the next step we will obtain the pure metal, okay, that is metal will be obtained. Now those metals which are in the middle activity series, so for this purpose if we just look back to that chart, those who are in medium reactivity, for them two conditions we have got sulfide ore and carbonate ore. If it is sulfide ore, then we will go through the process known as roasting to obtain the oxide of metal. If it is carbonate ore, then we will go through the process calcination to get the oxide of metal, and then reduction to metal. So as they are in the middle activity series, suppose zinc, iron, lead, whose position in the middle of the activity series, so for them two ores we will consider, that is two forms of ore are mostly found. Here one example taken for zinc. Now you know that we will go through two process known as roasting and calcination. Now what is roasting and what is calcination? Roasting means what? This is the process in which sulfide ores are converted into its oxide by heating strongly in presence of excess air. That means in excess air sulfide ores will be heated to get the oxide of that metal, and this process of heating sulfide ore in excess air to get the oxide of metal is known as roasting, okay. And what is calcination? Calcination means what? The carbonate ore, same thing, the carbonate ores are converted into its the carbonates ore are converted into its oxide form by heating in limited amount of air. That is, air will be limited to get the oxide of metal, which is known as calcination. So that's why you see suppose for sulfide or zinc sulfide taken, okay, in this zinc sulfide you see as it is sulfide ore, so we'll go through the process roasting. So in roasting what is done, this sulfide ore is allowed to react with oxygen, heating is going on to get the oxide of metal, that is, as it is zinc sulfide, so we have got zinc oxide and the release of sulfur dioxide gas. So in the first step we have removed sulfur. Now you see if it is carbonate ore, then what would happen? Here it would be heated in limited amount of air, so there will be no reaction with oxygen, rather this zinc carbonate will decompose to form zinc oxide and carbon dioxide gas will be released. So we have got the oxide of the metal, right? If it is sulfide ore, then we will go through roasting to get the oxide of metal. If it is carbonate ore, we will go through calcination to get the oxide of metal. After obtaining the oxide of metal, it is very easy to extract to obtain the original metal. So just oxide of metal, it is allowed to react with carbon, coke, right? And then what is going on, reduction of this zinc oxide would take place. As a result we will get zinc with carbon monoxide. If other than zinc, if it is suppose if it is iron, then it would be iron oxide. When it is allowed to react with carbon, we will get iron plus carbon monoxide. So this is the process to extract a metal whose position in the middle of the activity series. Now there might be a question that why should we convert this sulfide or carbonate ore into its oxide? Because you see to extract a metal or to obtain a metal from its oxide form is very easier, because through a simple reduction process we can obtain the metal. That's why we are converting the sulfide form or carbonate form into oxide, so that we can extract the metal easily. Now one more question might be that is the only element carbon, or is it the only process by using which we can extract the metal from its oxide? The answer would be no, because you see this is nothing but a displacement reaction, we can say, right? As carbon displaces zinc, that's why carbon monoxide plus zinc, right? So the oxide form of any other metal, without using carbon also we can get the metal. Just the condition might be, the condition is that the metal which we are going to use, that should be more reactive than the oxide of that metal. Suppose if one example is taken, then it will be very clear to you. Here you see manganese oxide, okay, so oxide of manganese. So you see here aluminium is taken, which is more reactive than manganese. So what would happen here? A displacement reaction will take place. As a result, we are getting manganese along with what? Aluminium oxide plus heat. So you see we have obtained manganese from manganese oxide without using carbon, that is by using aluminium, because you see aluminium is more reactive than manganese, so aluminium will displace manganese. As a result, we will obtain manganese. So without using carbon also, from the oxide of any metal we can extract or we can obtain the metal. Just the condition is that we have to use one metal which is more reactive than that metal's oxide, so that a displacement reaction can take place. Because the condition of displacement reaction is that the reaction in which more reactive element will displace the less reactive element from its compound, right? It's very well known term or reaction. Now one very important reaction here you see, that is Thermite reaction, okay, very important reaction, remember, Thermite reaction. So this is the reaction of what? Iron oxide with aluminium to get iron plus aluminium oxide plus heat. Here also you see oxide of iron. So from oxide of iron we are getting what? Iron, just by a displacement reaction with aluminium, right? That means aluminium displaces iron from iron oxide to form what? Iron plus aluminium oxide. Now this reaction is known as actually Thermite reaction is what? The highly exothermic reaction of metal oxide with aluminium to obtain aluminium oxide, that is to get the metal and the aluminium oxide. The reaction is highly exothermic, that means a huge amount of heat would be released. That's why iron in the form of molten state we will get. Now what is the importance, what is the significance of this reaction? This reaction is used while joining the cracked, that is what, railway parts, to join the railway tracks or cracked machinery parts. While it is joined, at the time this Thermite reaction is used, where this iron oxide nothing but rust. It is allowed to react with aluminium, as the reaction is very exothermic, a huge amount of heat releases, so that heat actually melts the iron. That's why iron is obtained in the form of molten state along with aluminium oxide. So this is about what? Those who are in the middle of the activity series, okay, and how they have been obtained. Now the last one, that is for this new syllabus, as per the revised syllabus, this is the last one, extracting metals towards the top of the activity series. So whose position in the top of the activity series, how they have been extracted. Okay, thank you for today. In the next video we will discuss this last topic. Okay, take care.